Hello. Our aim in this video is to find the antiderivative of the fraction exponential of sine of x divided by cosecant of 2x. This is a classical calculus problem. We will carefully walk you through the solution. This problem is an interesting problem because it involves the exponential function and two trigonometric functions. We certainly need to construct a good strategy to solve it. This strategy will involve using our basic trigonometric identities. It is always beneficial to analyze the function that we are asked to integrate. This initial analysis of the function will help us figure out how to solve it efficiently. We first notice that cosecant of x can be expressed as 1 over sine of x. This will allow us to greatly simplify the expression of the function we want to integrate. So, we have f of x, which is equal to exponential of sine of x divided by secant square of x, is now equal to cosine square of x times exponential of sine of x. This is a very interesting expression of the function we want to integrate. Because there are great differential relationships between sine of x and cosine of x. We will be using those relationships to transform the integral itself. This implies that we should first start with the substitution method. It is evident that the natural choice for the substitution parameter w should be the inner function. Thus, w should be sine of x. So, we set w equal to sine of x and dw should be equal to cosine of x dx. So the integral of the fraction exponential of sine of x over cosecant of 2x dx, becomes the integral of 2 times sine of x times exponential of sine of x times cosine of x dx. Which can be simply written as the integral of 2w times exponential of w dw. This version of the integral is naturally simpler than the original version. Please like the video and subscribe to our channel. Thanks to those who have already done so. Let us integrate the function 2w times exponential of w. As a matter of fact, at first glance, we easily see that the function we have to integrate is a product of a nonlinear function, exponential of w, with a polynomial function 2w. Usually, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem, and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2, for solving integrals that involve the products or quotients of nonlinear functions are the u-substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. Actually, the polynomial function 2w is of degree 1. Then, our first goal will be to reduce the degree of the polynomial function to 0, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. Thus, we set u equal to 2w, so du equals 2 dw. And, dv equals to exponential of w dw, and v equals to exponential of w. In sum, the integral of 2w times exponential of w dw is equal to 2w times exponential of w, plus, minus 2 times exponential of w, plus a constant c. Now, replacing w by sine of x, we see that the integral of 2 times sine of x times cosine of x times exponential of sine of x dx is equal to 2 times sine of x times exponential of sine of x minus 2 times exponential of sine of x plus a constant of integration c. Finally, the integral of the quotient, exponential of sine of x divided by cosecant of 2x dx, is equal to 2 times sine of x times exponential of sine of x minus 2 times exponential of sine of x plus a constant of integration c. Thank you for viewing this video. Please like the video and subscribe to our channel. We have an extensive collection of calculus videos covering limits, derivatives, series, integration, and many other calculus-related topics such as probability and differential equations.